class. Sorry I can't be here today, but I am still going to lecture on how ionic and metallic bonding occurs in chapter 7. So if you have any questions, please feel free to email or Edmodo me. I'll try to get back to you as soon as possible. Or ask someone at your pod, as someone may be able to answer your questions. Please feel free to stop or pause the recording anytime you need to. These are available on Edmodo, so if you need to review them throughout the week, feel free to do that. So today, what we will do is we will learn about a couple features, such as the term valence electrons and how that's important in bonding. We'll also learn about the octet rule. This is everything that the elements are striving for, as well as the differences and the similarities in cations and anions. So please pull out your notebooks, a pen, pencil, whatever it may be. You will also need your periodic table throughout this section. So what I will do is first go into valence electrons. And as you can see, valence electrons are electrons who are on the outermost ring when we are looking at energy levels. So since we've been doing electron configurations, we've looked at the very first electron that enters up until the very last electron that enters. However, now that we know some of the energy levels are filled, we're really going to make our focus onto the highest occupied energy levels. And just like you have seen, the periodic table is set up in a manner where we tend to see different trends and periods and traits within certain characteristics of the placement of the atoms on the periodic table. So we are going to take a look at why these valence electrons are very important, and we'll be doing a lot of drawing and referring back to the periodic table, so make sure you're prepared for that. Okay, so what I need you guys to do is copy this chart down. We are going to fill this chart out, but I'm going to walk you through the process using the periodic table. So please write down all these elements in group 3. Specifically, this should say group 3A. Right there. But please list down boron, aluminum, gallium, and indium. And we are going to fill out the electron configurations. Like I said, I'm going to flip over to the periodic table, but we will fill this chart out together. So our very first element is boron, right? So like we said, we are in column 3A. So I know I am right here. And our very first element is boron. So I'm taking a look at boron right here. Okay? So just to refresh your memory, the periodic table is broken apart into the different orbitals that it may hold on to. So the very first two columns, column 1A and 2A, will always be in charge of the s orbitals. So I know these only fill the s orbitals. The transition metals right next to them, right here, fill a different letter orbital. Which orbital is that? Okay, so hopefully somebody said the d orbital. So I know these 10 rows fill up the d orbital. And finally, our last set of orbitals are the p orbitals over here. Okay. So what we do is we go through this process and see what rows and what electron configurations are going to be filled up until we get to boron. So if I use arrows, let's use this arrow right here. Since we know we start with electron 1, I know I have to fill these electrons right here before I can start level 2, right? So as you can see, this is in row 1. And since I only have 2 elements here, I know I have to fill the s orbital. So this is 1s. Once I get to helium, I I'm at 2, correct? So now I'm going to do the same process, but I'm going to jump to level 2. So I'm going to go here, and I'm going to stop right there at boron, since I know this is the element we're taking a look at. So as you can see, we are in row 2. So I know I'm in row 2. These two sections right here, as I can see from down here, fill this s orbital. So I write in an s, and I fill in 2, since 2 spots were taken. Then I have to jump over to this section. And as you can tell, I'm still in row 2, but now I'm under the P section, so I label P. And how many elements do I have under that area? I only have this one right here, so I have 2s2, 2p1. So if I were to combine this with everything that we've seen, I'm going to take my chart and fill this in appropriately with 1s2, 2s2, and 2p1. And what's one way to make sure that we always have the right elements? Good. Add up my exponents, and they need to equal my atomic number. So if you take a look here, 2 plus 2 plus 1 is equal to 5, which is my atomic number for boron. Good. So I'd like you to do the next element, which is aluminum. So I'm going to clear up my writing. And I will relabel this as S, D, and P. So if we do the process for aluminum quickly, now this arrow is going to extend till the end over here. And I will need to draw another arrow right here, which will stop at aluminum. So if I take the same process that we just completed, this first line is 1s, and I have 2 elements, so I hit 2. Second line is 2s, so I hit these 2 right here, which gives me a 2. And then I jump to 2p, which is all of these right here. So if I count, I have 1, 2, 3, 4, 5, and 6, which gives me 2p6. And now I jump to these 2 over here. Since I'm in row 3, I write a 3. Since I'm at S, I write S2, since I have 2 elements there. And finally, I go over here, which is still in row 3, but since I'm at orbital P, I write a P, and I only have 1 element here, so I will write this 1. Once again, if I total these up, I get 2, 4, 10, 12, 13, which is the same exact number I have for the atomic number of aluminum. So hopefully when you fill these out, you wrote down 1s2, 2s2, 2p6, 3s2, and 3p1. Okay, so now we're going to take a look at gallium. And this is slightly different from what we have because we have entered a new level that has different orbitals to fill up. So just as our guide, once again, S, D, and P, right? So now that I'm looking at gallium, I extend this line all the way here. And then I take this entire section up until gallium. Okay? So can anyone guess which orbitals we need to incorporate? Good. So my peach section, which is your purple section on your periodic table, tells me I need to incorporate this D level. Okay? So let's do this again. This section right here will give me 1s2, just like last time. This one also like last time is 2s2, 2p6 because of all of these right here. This right here will give me my 3s2. And now I count all 6 of these, which is 3p6. And now I need to jump down to row 4. So since I'm in row 4, I know that gives me 4s2. And now I have these d orbitals. So I know I'm at d, and I've hit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know I'm at d10. But because we are at a d orbital, what's the rule once I hit the transition metals? Correct. I need to go one level below, which means this D section is actually part of 3D10. Okay. So once I'm in this D section right here, my level is actually one less than the row that I'm at. And if I finish this off, I have one electron, which is in level 4p1. Good. So what I'm going to do is fill in our box again. You might have to squeeze this in. But gallium has 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p1. Good. So now it's your turn. I'd like you to fill in the electron configuration for indium, which is the element right below gallium. Once you do this, I'd like you to highlight every single orbital which is in the highest energy for each one. Okay, so please fill in indium. Highlight your highest energy orbitals. And then I want you to think about this question. How many electrons are in the highest energy level? So I will stop this video here for you to work on indium and to work on your highlighting. And in the next video, I will give you the answer.